Hello everybody, welcome back to my channel. I am Pravansu Kumar Singh. You ready to dive deeper into the world of microtasks and macrotask queues in JavaScript? Today I will be showcasing the code demonstration to understand how these queues work and how they impact the order of execution of our tasks. So let's jump right into the code and unravel the mysteries of microtask and macrotask queues. Okay, we'll start by recapping the concepts of event loop that we have discussed in our previous videos. So we see here, this is the life cycle or basically a continuous process of the event loop execution of the task. So here we see there are numbers of callbacks. For example, the timer callbacks, input output callbacks, check callbacks, and the close handlers. These all things comes under macro task queues. Now the process.next tick callbacks and the promises callbacks comes under the micro task queues. Now we will talk about the priority level of the these tasks. So timer callbacks or input output callbacks or whatever the task that is inside a macro task queues has the lowest priority than the micro task queues. So that means process.next tick callbacks and the promises have the higher priority as compared to the macro task queues, right? So even inside a macro task queues, we have a priority in the callbacks. So the timer callbacks, for example, set timeout and set interval callbacks has the highest priority. The second highest priority is to the input output callbacks. And the third highest priority is the check callbacks or set immediate callbacks. And the fourth priority or is given to the close handlers. In the same way, inside a microtask queues, we also have a priority priority in the callback execution. For example, the process.next tick has the higher priority than the promises callback. So I have written here some JavaScript code that consists of macrotask and microtask callbacks. So if you are going through this code, we see here the set interval which comes under a macrotask queues and set timeout again inside a microtask queues. Then we have promises that comes under a microtask queues. That means now we are actually examining how the priority works, how the order of execution happens inside the event loop. So we'll see here how it works. Let me split the code. Okay. So in the code we see here there is a set interval, set timeout and promises. All are asynchronous code. Execute this code and we'll see the order of execution of the tasks. So right now we see first of all the first console log get printed, that is script start. After that the set interval callbacks is not printed. Even the set timeout callback is not printed. The last one, that is the promise.resolve, that get printed. Why the promise get printed? Because the microtask queue has the higher priority. So whatever the callbacks we have in a microtask queue, that will be taken first for the execution, and then only once the microtask queue is totally empty, then only the call stack will pull the code from the macro task. So here, since we have a promises, so first it will print, it has printed promises 1 and promises 2. Now I'll show you here. I have created one kind of priority based and how the things are going on while executing this code. So when we first of all execute this code from top to down approach, set interval and set timeout 1, that means this set interval and this set timeout function moves to the macro task queues, the callbacks of these functions. And the micro task queues, in the micro task queues, the promises 1 and the promises 2, which are the which are on inside the callbacks, get moved on. So these things are promises have the highest priority as it belongs to the microtask queues, so it get executed first. That's why, that is the reason why we are able to see the promise 1 and promise 2 get printed first, even this promises is in the last of the script. Now we'll see if after the promises get all the promises get executed, what will happen. The microtask queue is empty. Now it will the event loop will take first task from the, or basically single task from the macro task queues. So here is set interval and set timeout. Obviously set interval is in the first position, it will take that one because both the callbacks belongs to the timer queue. So here we have no way to prioritize this and that, right? So set interval, and then we see the set interval get printed. So this get printed. Once the set interval get printed again, since it keeps on repeating until we clear this interval, so it the another interval callback again moves to the macro task queues. So right now this set interval get set timeout interval get printed. Now after that, the set timeout one, it will check if there is anything inside the promises. Again, we don't have anything inside the promises, then it will print set timeout 1 as it is inside the callback of set timeout 1. So if you see here, after the set interval, set timeout 1 is there. Now once the set timeout callback get executed, inside that callback there is a promise, and these promise callbacks uh, get queued in a micro task queue. Even you see here in the right, we have center set interval set timeout. After that execution we have set timeout 1, this one. After this execution we have a macro task set interval inside a macro task queues. But after each execution of the task from the macro task queue, the event loop checks whether anything is there in the microtask queues or not. And after the execution of the set timeout 1, it will it checked in the microtask queue and it found there is a promise 3 and 4. So it will actually it executes the microtask as it has the high priorities. So the callbacks of the promises 3, the callbacks that is promise 3 and 4 get printed. Now once these all the tasks inside a callbacks inside a promises or microtask queue get emptied, then again it will check whether anything is inside a macrotask queue or not. Now in the macrotask queue, again it find there is a set interval, then it will execute that set interval callbacks and it will print again the set interval. So you see here the set timeout 1, after that promise 3, after that promise 4, again set interval. Now, once the set interval is executed, inside the promise callbacks in the dot then function, we have again the set timeout. And that timeout is already in the queue. So what happened after completing the task callbacks from the micro task queues, it will again check whether anything is inside a macro task queue or not. Yeah, there is a macro task, something inside a macro task queue. The callbacks related to set timeout that is inside the dot then function. So it will print set timeout 2, right? After that, once the callback of set timeout 2 here get executed, inside that there is a promises. Obviously that get queued in a microtask queues, and again that will print those promises in the end. After that, in the dot then function, we have a clear interval. That's why in the last step we are not printing the set interval because it is getting cleared before its execution. Now we'll see some scripts. So here we have a fs.read file that is again input output call, and then set timeout, that is a timer callback. Set immediate, again it is a check queue callbacks. Then process.next, this is the callbacks, that is this function has the callbacks that is related to the that comes under the microtask queue. So we'll see here what will get printed in this kind of scenario. We have covered here all the almost three kinds of macrotask queues, callbacks of the macrotask queues, and one type of callbacks inside a microtask queues. So we'll see here. So let's execute each. Sorry, node event loop. Yeah. So if we see the response, here we can find current event loop, which is directly the console log in the script in the global function on the root level, that get executed first, because all the others are in the asynchronous call that will be overloaded to the libviv for its execution. But the console.log, that is current event loop, that gets executed instantly, because that is handled by the call stack itself, by the main thread itself. Yeah. After that, we see here the first position is read file, then set timeout and set immediate, and then promise.next is. But the microtask consists process.next is next tick. That's why that get printed first, because microtask has higher priority than the macrotask. So if you see here, next tick get printed first. Now, yeah, the input output callbacks, set timeout callbacks, and set immediate callbacks, these all things are all callbacks are inside a macrotask queues. But inside that, there is again a priority one. So timer callbacks always get the highest priority. So we see here the set timeout, which is in the second position, get printed first. That means we get timeout. After that, the set immediate get printed, and then we see, okay, there is a immediate, and the last priority given to the input out the fs.read file. And there you have it, guys. We have successfully explored the concept of microtask and macrotask queues in JavaScript through our code demonstration. By understanding the order of execution and the priority of these tasks, we can now write more efficient and responsive code. Remember, microtasks allow us to handle the high priority tasks promptly, while macrotasks handle long and time consuming operations. By balancing these queues, effectively ensures the smooth user experience and optimized performance. So keep experimenting, exploring, learning, and leveraging the power of microtask and macrotask queues in your JavaScript. Happy coding.